Okay, so today what we're doing is the third type of way of solving simultaneous equations, and that's elimination. Now, elimination is really good when you have equations that look like this. So x plus y equals 5 and 2x plus y equals 7. Those two, good, minus 4x minus 2y equals negative 8. 4x plus 3y equals 10. So you'll notice that in these, the x and the y is on one side and the numbers on the other. So the x and the y on side and the numbers on the other. So as the word elimination suggests, we've got to eliminate something. So we either add or subtract the equations together to eliminate. Now, not only do we just add or subtract, we need to also make sure that the number in front of either the x or the y is the same. Just the size part doesn't matter whether it's positive or negative. So in this first one, you'll notice that we've got one y here and one y there. In the second one, you'll notice we've got a 4 there and there. This one's a minus and this one's not. So that then gets to, do you add or do you subtract? Now, if, as in these first two, there's a plus here and a plus 2 there, so if we've got a plus and a plus, or a minus and a minus, then for those we will need to subtract. But where we've got opposite signs, like we've got a minus 4 here and a plus 4 there, so a minus and a plus, we then add our two things together. So let's have a look at a couple of examples. So one example, we've got equations x plus y equals 6 and 3x minus y equals 10. So that's a 1y, that's a minus 1y, and because we've got a plus and a minus, that means that we're going to add. So if I add, and the way I add is I add down these columns, so I add those, so x plus 3x, and when I do that I get 4x. Then this is where the elimination bit goes. When I add those, I've got plus 1y plus negative 1y, and a plus and a minus together is a minus, so the y is gone, so the y is eliminated. 6 plus 10, 16, divide by 4, x equals 4. So to find the y then, we use one of those, and it's a bit messy over there, so if I use x plus y equals 6, I would then know that 4 plus y equals 6, and so y equals 2. So these equations will intersect at 4 and 2. Alright, so that one there is not too bad. But what if we've got something like these? So we didn't have to actually do anything there, we could just add or subtract. But what if we've got something that looks like this? So I've got y, and I've got y minus 3x equals 1, and 2y plus 5x equals 13. Now when we look at the numbers in front of the y's, there's a 1 there, a 2 there. When we look at the numbers in front of the x's, there's a minus 3 there and a plus 5 there. They're not the same. So we need to, somehow or other, get those numbers the same. Now there's a multitude of different ways that you can do it. But the simplest way is when we look here at the y's. Alright, so we've got one y in the top one and 2 in there. So if I was just to multiply all of this top one by 2, then I would have 2y, all of it, minus 6x equals 2. And then I have 2y plus 5x equals 13. Now, here we've got positive and a positive, so if we've got a positive and positive, we need to subtract. So we'll go 2y minus 2y, that's 0. Then we've got minus 6 minus another 5, that would be minus 11x. And then I've got 2 minus 13, which would be negative 11, divided by negative 11, and x is 1. So to find y, we substitute it back into one of those, and I'll squeeze that over here. Only use the top one. So I've got y minus 3 times 1 equals 1, so y minus 3 equals 1, add 4 to both sides, and y, 3 to both sides, and y equals 4, getting ahead of myself. So 1 and 4 is the point of intersection. Alright, so that's kind of a couple of quick examples of how we go about it. So now you're looking at the exercise 1K stuff on your work from